Hi, my name is Kaylee and today I'll be taking you through the basics on recognizing inversion symmetry. Here are some of the learning goals for this video. First, we're going to learn how to define inversion symmetry and the basic terms that are related to it, and then we'll learn how to carry out an inversion on a molecule. And finally, we're going to learn how to recognize whether a molecule has inversion symmetry or not. First, let's get an idea of what molecular symmetry is. The textbook definition of molecular symmetry is a permutation of atoms such that the molecule is transformed into a state indistinguishable from the starting state. Put more simply, this means that when a symmetry operation is carried out, the molecule will look exactly the same as when you started. Now I'm going to take you through a few examples of molecular symmetry. If you see this chair here, we can draw a line down through the center. And as you can see on both sides, it's going to look exactly the same. Both sides have an arm, both sides have two legs. They both look exactly the same. You can basically fold it in half and it'll look exactly the same on both sides. A molecular example of this would be the water molecule. You can see that they've already drawn the plane here for you, and you can flip it on both sides and it's just going to be just like the chair. You fold it over and it looks exactly the same on both sides. So this plane is actually going to be called a reflection plane. And it's going to indicate that the molecule has reflection symmetry. The next example I'm going to take you through is going to be starting with this lamp. If you can imagine that there's an axis here, just like on the Earth. It's going to go down through the center of this lamp here, down to the base. And if you were to spin this lamp around this axis, in any direction, any way that you configure it, it's going to look exactly the same as the starting position. So a molecular example of this is going to be the ethane molecule. If you draw your axis again, from there through there. And with the ethane molecule, any way you turn it isn't going to give you the exact same configuration, but there are ways in which you can turn it to make it look exactly the same as the starting configuration. And this axis is going to be called the rotation axis. And this is going to be an indication of rotation symmetry. Alright, now we're going to take a look at a Jack's game piece. If you were to draw a point at the center of this game piece, and you were to pass each of these little arms through that center, just as these arrows do, at an equal distance from what they are currently from that center, then you're going to end up with the exact same configuration. It's going to look exactly the same once you pass these arms through as it does when you started it. Alright, so a molecular example of this is going to be the benzene molecule. You'll see the inversion center right here. And you're going to pass each of these little different colored CH molecules through. And as you'll see, the orange is now down here on the other side at an equal distance, and all these other ones are flipped as well. And it looks exactly the same as the starting configuration. Nothing has changed other than the colors are on the opposite side. So this is going to be called an inversion center. That little dot in the center is the inversion center. And it is an example of inversion symmetry, which is what we're going to be mainly discussing today. So now that we've gone over some of the important things surrounding molecular symmetry, we're going to go into a little bit more depth on some of the definitions that surround inversion symmetry specifically. So first we have an inversion. So just like in the operations we carried out with the benzene molecule and the Jack's piece, you just pass each point through the center of inversion and out to the same distance on the other side. Center of inversion is the point through which you carry out the inversion operation. And lastly is inversion symmetry, which is when the starting molecule is indistinguishable from the new molecule when an inversion operation is carried out. So now that you know the basics of inversions, how can you carry one out? First, you're going to draw a dot at the center of the molecule to represent the center of inversion, and then you'll pass all molecular parts through the center of inversion. After you carry out an inversion on a molecule, how do you tell if that inversion has symmetry? So first you can compare the starting configuration with the new configuration, and if the two configurations are indistinguishable from one another, then that molecule has inversion symmetry, and if they are not, then it does not have inversion symmetry. Here's a diagram to help you get a better idea of how an inversion works. So you're going to start with your center of inversion as seen here, and you're going to pass each of these arms through. So 1 is going to become 6, and 6 is going to become 1, and all of these for each and every single one of these arms here. This is going to be an inversion here, and as you can see, once the inversion is complete, this new molecule over here is completely identical to the other one over here. The only difference is these numbers are flipped, so that's going to indicate for you that this molecule does have inversion symmetry. Now I have another little video or demonstration here to show you how inversion symmetry works. This just gives you like a little animation so that you can get a better visualization of how the inversion happens. So she's set her little inversion center right there, and you can see it's pretty fast, but you can see that they pass through and it looks exactly the same as when you started. Let's walk through a couple more examples and determine if they have inversion symmetry or not. First, I'm going to draw my inversion center right here, as you always do for performing an inversion. So I'm going to mark this as 1, 2, 3, and then that's going to be 3 prime, 1 prime, and 2 prime. So if you pass 1 through the inversion center, it's going to go right on through to 1 prime. 2, pass it through the inversion center, you're going to get to 2 prime. 3, pass it through the inversion center, and you're going to get 3 prime. So you can see if you were to flip that, it's going to look exactly the same as the starting configuration. So therefore, it does have inversion symmetry. Next, we're going to look at the water molecule. If you remember from the beginning of the video, water does have reflection symmetry, but we're going to figure out right now if it has inversion symmetry as well. So like always, we're going to try and place our center of inversion. So let's say we place it right here. Let's say we're going to pass that H through. Let me get a better color. I'm going to pass that H through. It's going to be over here. Pass the other H through. It's going to be over here. And you're going to see that anywhere that you place the center of inversion on this water molecule, no matter what you do, you're not going to get the same configuration as the starting configuration. So you can therefore tell for sure that it doesn't have inversion symmetry. For our last example, we're going to look at a octahedral molecule. So we're going to place our center of inversion right there. We'll make this 1, 2, 3, 4, 5, and 6. So if you were to pass 6 through, it's going to go out to 1, and vice versa. 4 is going to go to 2, and vice versa. 5 is going to go to 3, and vice versa. So once all of those inversions happen, it's going to look exactly the same as the starting configuration, so therefore you can tell that it does in fact have inversion symmetry. Going back to the learning goals, you can now define inversion symmetry as when the starting molecule is indistinguishable from the new molecule when an inversion is carried out, and you also know what the center of inversion and inversion function are. You also learn the steps to carry out an inversion, just like we did with ethane, water, and other examples. And finally, you know how to recognize if a molecule has inversion symmetry or not. So congratulations on your new knowledge of inversion symmetry, and thank you for watching.